Hi everyone. In this section we are going to start off by looking at arithmetic sequences. Now something very important to remember is that an arithmetic sequence has a first constant difference. So let's go see what it is. So in this warm-up, we are going to see if you can calculate the first constant difference. So here is the first sequence. It's 2, 5, 8 and 11. So what I want to know is, what do you have to add or subtract from 2 to get 5, and to go from 5 to get an 8, to go from 8 to get an 11? Okay, so can you do that? Very good. It's a plus 3. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So this 3 is the first constant difference for this sequence. Now let's look at the next one. 2 minus 3 minus 8 minus 13. Now what do we have to add or subtract from 2 to get a minus 3? Did you get it? Good. Yes, it is a minus 5. So 2 minus 5 is minus 3. Minus 3 minus 5 is minus 8. Minus 8 minus 5 is minus 13. So this minus 5 is the first constant difference for this sequence. Now let's see if you can do the last one by yourself. So here we have minus 13, minus 4, 5 and 14. What is the first constant difference? Did you get it? Excellent. Yes, it is a plus 9. So minus 13 plus 9 is minus 4. Minus 4 plus 9 is 5. And 5 plus 9 is 14. So you just calculated the first constant differences for each of these sequences. So now in the lesson we're going to find the easier way to calculate it, as well as find the general formula for an arithmetic sequence. To learn these two new concepts, we are going to make use of the following sequence. Now 5, 8, 11, and so the sequence continues up to a certain number that we don't know what it is and where it ends. Okay, so this 5 is called T1. That's the term in the first position. So 5 is the term and it's in the first position. It's the first number in the sequence. This 8 is called T2, so it's the term in the second position. This 11 is called T3 and it's the term in the third position. And so the sequence continues up to a certain point where we don't know where the sequence stops. We don't know that position. We call that value in that unknown position Tn. That's the term in the unknown position. Now, this is an arithmetic sequence. So for us to be able to calculate the constant difference in an arithmetic sequence, well, basically I think you already know what it is because of the warm-up. So you know that 5 plus 3 is 8 and 8 plus 3 is 11. But there is an easy way so that we make sure that we've got the signs correct and that we don't make a mistake with the first constant difference. So we use the following formula. So here it is. It's D equals term 2 minus term 1. Now this D is the symbol for a first constant difference. So a small letter D is the symbol for a first constant difference. So what we're going to do is we're going to take term 2, which is an 8, minus term 1, which is the 5, and then we will end up with our first constant difference, which is a positive 3. So let's just make sure that we have it correct. So 5 plus 3 is 8. 8 plus 3 is 11, and 11 plus 3, and yes, you've got it, it's 14. So we know that the first constant difference is a positive 3. Now we want to calculate the general formula. Okay, and to be able to do that, we are going to make use of the following formula. So yes, we're going to use a formula to calculate the general formula for an arithmetic sequence. So the term in the unknown position is equal to A. Now this A is term 1. It's this 5. And then plus D, which is our constant difference. And in brackets, we've got N minus 1 and we close the bracket. Now that N is the unknown position because we want to calculate the values in unknown position and we don't know what that position is. So let's just do normal substitution. In the place of the A, we're going to put the 5 because it's term 1. And in the place of the D, we're going to put the plus 3, which we calculated earlier. So just to remind you that if this was a negative 3, for example, this would be a minus 3. But in this case, we've got a positive 3, so the constant difference is a positive 3. Now, the next thing that we do is we simply do distributive law. So a positive 3 times n, and then the positive 3 times minus 1, and then we end up with the following. So the term in the unknown position is equal to 5 plus 3n minus 3. Okay, and then what we do is we just write 3n, and then 5 minus 3 gives us this positive 2. And this is the general formula for an arithmetic sequence. It's always in the form of Tn is equal to our constant difference times n. Now in this case the constant difference was a 3. And then plus c, which is just a constant value that makes this entire sequence true. So if I can quickly show you the way that we can check if we are correct is if we take this 3, which is the constant difference, plus the c, which is 2, we will get term 1. And there we go. So 3 plus 2 is 5. And that's it. So this is our general formula. And in the next lesson, we will learn why this general formula is so important and how we can use it.